Alright, Lesson 7, the last lesson in Unit 8, Angles of Elevation and Depression. So, this is just a generic example of angles of elevation and angles of depression, and all we're basically doing in this is applying our ideas of trig. We're going to be applying trig into the real world and using it in scenarios that you may not really see, but it's places where they are used. So, start off with an angle of elevation is an angle that's created whenever you go up from a line of sight. A line of sight is just any flat line. Sometimes it's imaginary, sometimes it's not. If you can think about it, it's like if you were standing looking straight at a wall, there's an imaginary line between your eyes and the wall. That would be a line of sight. Or a lot of times we use the ground as our line of sight, since the ground is normally flat, or we assume it's flat. So anything coming up from the ground would be an angle of elevation. An angle of depression is anything going down from a line of sight. Now we could think about this as you were standing on the ground and you were to dig at an angle, or we consider it like you're at the top of a mountain and you're looking down into a valley. Your line of sight would be out over the mountain, and then as you look down, you create an angle looking down to the valley. So that would be an angle of depression. So now we're just going to have some scenarios. So right here we have a flag, and what's going on is you're being tasked with adding a support wire to this flagpole. The problem is you don't know how tall the flagpole is, which also means you don't know how much of steel you need to make your support wire. So what you got to do is you have to figure out Y, which is the height of the flagpole, and X, which is the steel beam or the steel wire you're going to use to support the flag. What we do know is that we are standing 30 feet away from the base of the flagpole. That's what this line is. This will be our line of sight. And we measured a 40-degree angle up to the flagpole. So we can use this information to figure out how tall the flagpole is and how much steel wire we're going to need. So let's start by finding Y, finding out how tall the flagpole is. So I look, and I look at my 40 degree, Y is opposite, 30 feet is adjacent, opposite and adjacent tells me I need to use tangent. So the tangent of 40 degrees is equal to Y over 30, multiply both sides by 30, and we get Y equals 30 times the tangent of 40 degrees. And let's just round this to the nearest tenth. Put my degree symbol in the right place. And we plug this in a calculator and we get it's 25.2 feet tall. So we know the flagpole is 25.2 feet tall. Now we need to figure out the support wire, X. So again, we look at our angle. X is the hypotenuse, 30 is adjacent. Adjacent and hypotenuse is cosine. So we're going to do the cosine. I'm just going to make a line here to give myself some space. The cosine of 40 is equal to 30 over X. And to solve this quicker, we're just going to do that trick where we switch these two. So we get X is equal to 30 divided by the cosine of 40 degrees. And again, make sure your calculator is in degree mode when you do this. So you get x equals 39.2 feet. So in order to build our support wire, looks like we need 39.2 feet of rope or wire at least. Okay, the next problem is we are standing on top of a mountain way up high, and down below us we see a city. We look and we measure from the top of the mountain down this angle and see that it's 20 degrees. We're wondering how far away is the bottom of the mountain right here to the city. So in your group, I want you to recognize what trig we're going to use to figure this out. Then I want you to solve how far the mountain is to the city. So go ahead and pause the video and do that now. Okay. We look at the 20 and we're trying to find the opposite, and we know the adjacent. So that's going to be tangent. So the tangent of 20 equals x over 700. Multiply both sides by 700. So 700 times the tangent of 20 will be 254.8 meters. So our mountain is 254.8 meters away from the city. The next example, we are in a flight tower here, in an air traffic control tower, and there's an airplane coming in to land. The airplane tells us that it's 2,000 feet in the air and that it's about 10,000 feet from the runway. Now we're going to forget about how fast it's going here just for the sake of the problem. And we're going to, the pilot wants to know, what should my angle of descent be? Because that's something that they need to figure out. They need to say, well, how many degrees should I be descending? So you're going to figure that out. So in your group, figure out which trig ratio you need to use. And notice we're solving for an angle now. So that's a bit different than a side. And then try the problem. So go ahead and pause the video now to work this out. Okay. See x, we have an opposite and an adjacent, and you'll find a lot of these angles of elevation and depression do use tangent. So we need the tangent. So the tangent of x is equal to 10,000 over 2,000. And these are really big numbers, so let's simplify that. Cancel out our zeros. 10 divided by 2 is 5. So we get the tangent of x equals 5. We need to take the tan inverse of both sides. And after that we get that x equals 78.7 degrees. So we're going to tell the pilot he needs to descend at degree measure of 78.7 in order to land safely. Alright, one more. It's Spider-Man. Spider-Man is going to shoot a web to swing on a building. Spider-Man is, for some reason, is really good at eyeballing distances, and he says that I am 500 yards away from that building. And he knows that there's a 60-degree angle to the building from where he's going to shoot the web. He's asking you, how long is my web going to be? So, you need to figure out which side of the triangle represents the web, and then solve for the web. So go ahead, pause the video, and do that now with your group. Alright, we really only have two choices to see which one's going to be the web. Is it going to be this or this? Well, this right here is part of the building, so we know it's not going to be that. So our hypotenuse has to be our web. So we look at our angle and we know the adjacent and hypotenuse, so it looks like we're going to use cosine. So the cosine of 60 degrees is going to be equal to our 500 over x. Now I'm going to do that switch. So we know that x equals 500 over the cosine of 60. And we find out that the web is 1,000 feet. So he's shooting a web out that is 1,000 feet long. And that is the end of this lesson, angles of elevation and depression.